Alright, so we are on problem set number 5. This is problems 24, 25, and 26. Let's start off with 24. So it says f is this, and it wants me to find f prime of 2. So another way of writing this is find the derivative, f prime, of the integral. Oh, it's not letting me go off there. Man. Alright, I'll have to write it over here. Alright, so d over dx of the integral from 0 to x like that. Well, we learned that when I find the derivative of an integral with x in, or my variable in my interval, we have one of 3 cases. Well, I'm going to look and see, well, my first value is a constant. The fact that one of them is a constant, specifically the first one's a constant, means that we're in either the first case or the second case. Then I'll look and see, well, the top one is just an x. So that means all I have to do is just plug x in and say square root of x cubed plus 1. And we're technically we're tacking on the derivative of x, but the derivative of x is just 1. Now that's not all I'm going to do, because it says I'm finding the derivative at 2. So we're going to plug 2 into our derivative. Plug 2 into there. So the square root of 2 cubed plus 1, well, that's 8 plus 1. That's the square root of 9, 3. That one right there. Okay. For number 25, again, they made it very much more explicit. They said, oh, d over dx of the integral from 0 to x of this. And they used u and du instead of t and dt. Doesn't matter. I'm just going to take that value, plug it in. Cosine of 2 pi x. Technically, I multiply by the derivative of x, which is just 1. Look and see, do I see that as an answer anywhere? Right there. And then for 26, I'm tempted to do the same thing. Be like, oh, I just did 2 problems like this. Take the x, plug it in, and I'd get a. And I would be wrong. Okay, that would be incorrect. And that would be incorrect because it doesn't tell me that I'm taking the derivative. Nowhere in here, see up here it says taking the derivative of the integral. Here was the derivative of the integral. Here, there is no derivative. No derivative on this one. So I actually have to take the integral. So, I'm going to work this problem out. If I do the integral of sine, I get negative cosine t, and I'm going from 0 to x. Well, our thing says we're going to plug x in, and then plug 0 in, and then subtract. So if I plug x in, I get negative cosine of x minus negative cosine of 0. Well, negative cosine of x is just negative cosine of x. Nothing much I can do with that. Cosine of 0 is 1, and minus a negative makes plus. So negative cosine plus 1. Well, I don't see a negative cosine of x plus 1, but I see a 1 minus cosine, and that's the same thing. All right.